Hi there, this is Mr. Ndelovet, your physics teacher. Today we want to do mathematics in ordinary level physics. So this will be those in Form 3 or grade 8, 9, 10. This is for you, and also those who Form 3, Form 4, and Form 5. This topic is for you. Now, the various mathematics relations that we need to know in physics is there are many. Like first, we need to talk about change of formulae. So one of the things that you'll be looking at, we have um, standard form. You need to know how to do standard form. You need to know trigonometry. You need to know how to use graph work as a graph. You need to know proportions. I need to know conversion of units. You need to understand percentages. And lastly, substitution and evaluation. So you need to know these things. So the first thing you need to understand it, you need to know how to manipulate equations in physics. If you cannot, then you will not be able to make it in physics. First thing first, when you're able to change a formula in an equation for the required quantities they are looking out for, then you're going to have a mark for that. Because one of the competency they are going to achieve in physics is that you need to know how to change a formula. And if you can achieve that, that competence is given a mark. Okay, today we are going to start with change of formulae. So we're going to start with change of formulae. Okay, let's start with change of formulae. So change of formula. So method 1. You're going to have equations in the form f equals to x times t, like this. And in physics, when you have equations in this form f equals x times t, they can ask you to look for x, to look for what, or t. Now this x or t, f, x, and t are all variables, or they're all called physical quantities. And so they can ask you to look for any of them. When the equation is like this, it means that you have to look out for f is the subject of the formula, but x and t are not the subject of the formula. When they say something is the subject of the formula, it means that that thing is standing on its own, like how f is like this, on one side on its own, and is equal to x times t. So how do we go about it? To go about it, the first method, what we do is that, for example, let's make x the subject. So you put your f equal to x equals t. So the first thing you do, you draw lines. You have to draw lines at the bottom. You have to draw lines at the bottom. Let me change the color so you see better. So okay, you have to draw lines like this, division lines. Draw division lines. Now, since the quantity the quantity or the physical quantity x is on the right and f is on the left, and these quantities are above this line that we have drawn. So what do? All the quantities beside the one you are looking out for, the one that you want it to stand on it on one side alone, since they're above the line, you take them below the line to the other side. So what do? I take this one, x is standing with t. So since t, for me to make x stand, I have to remove this t. And since t is above this line, I'll take it and bring it here below this line. So our equation now will have something like this. F on t will be equal to now x. So that's what we have. Now, if now we are making, so that's it, that will be your answer. So this will x now be the subject of the formula. Now, if you are making t, for example, okay, we are making t. We're making t. So I have this is f is equal to x times t. Now I want to make t the subject. You draw your lines. You draw your lines. Now x is the one that is above the line now. So you take x and bring here. You have f on x is equal to what? T. So this now you have made t the subject of the formula. You have made t now the subject of the formula. And we have various equations in physics that have this format. For example, we have various equations in physics that have this example. For example, we have F is equal to ma. That's the equation in physics. We have heat is equal to m mass times specific capacity times change in temperature. We have velocity is equal to frequency times lambda. We have an equation, yes, current, voltage is equal to current times resistance, like this. So they'll be giving equations like this. These are examples that you should look for. For example, if they give this one, they'll ask you to look for R, or they'll actually look for what? I. If they actually look for I or R, so what should you just need to take? Let me change the color so it is simple enough. So if I need to actually draw this line, if I'm making I, V equals IR, I draw the line, then I take my R this way. So I have V on R equals to what? I. Great. So now I would like you to pause the video and you do that for, this is F equals to M, A, make M the subject, and have 2, we have Q equals to M, C, make C the subject, and V equals to F times lambda, make F the subject. So if you can pause the video and do that, that would be great. Now, if you look at it, very well, so we have I know you have gotten it correct. So you have, for example, F equal to MA. You're looking for M, right? So what do you do? Actually, it's not coming out correct. So now we have to draw your line. I take my A this way. I have F over A equals to M. That's what we've done. The next, You have cure equals to MC delta theta. Now I'm making what? C the subject. So what should I do? Change the color to have draw your line, So you take what? M this way. Also take what? Delta theta this way. So you have Q on M delta theta equals to what? C. That's what you have done. So now the next one we had was V. You have V is equal to F lambda. So we had to, this one we have what? Divide, and you're making F the subject. So you take lambda this way. So you have V on lambda is equal to what? F. Great. Now, if you look at this, the next method that we are going to look at is equations method 2. Method 2. You see equations that have the form F is equal to X on C. You have equations in this form, F equals to X on C. Now, if you have equations in this form, what are you going to do to solve it? The first thing, as I said, we use the first method as we did. So let me show that color so that it's easier. Now we just draw a line, but this line maintains. Now the first thing, if you are doing X the subject of the formula, so what do? This T9 are below the line. Here we had, in this case, the A and M was above the line. This is line, this is a line here. It was above the line. So what do we need to do? We need to take this one below the line to the other side. Now, seeing this T now is below the line, we'll not take it below the line anymore. We'll take it above the line on the other side. So instead of that, we'll have to take it like this. So that's what we'll do. So you have now F times T is equal to what? X. That's what we're going to do. Yes. So now you have made X the subject of the formula like this. But now, if we are supposed to make, for example, let's say T the subject of the formula. So when you're doing T the subject of the formula, so we're having an F is equal to X on C. We have to do the first and the second method. So the first thing is that we do the line, as we have done. Now this line is below the line, so we take it above the line on the other side. And what do you have? You have now F T is equal to now X. We're not making the X the subject, we want the T. So now we'll do what we did in the first one, the first method. We'll draw another line. We'll draw another line. And now we take now F, which is beside T, and take it, because since it's above the line, now we take it below the line to the underside. And we have T is equal to X on what? On T. X on F, sorry. X on F. So we have made now T the subject of the formula. So in this method 2, you do two methods. You do method 1 and method 2 the same, like on 1, when you're looking forward for the one that is below the line, like below T. For example, we have equations in the form like I current is equal to charge on time. We have equation like V is equal to D on T. We have equation like pressure is equal to force on area. We have equations like power is equal to work done on time. We have equations like density is equal to mass on volume. And they can ask you to look for any of these things. So I'd like you to pause the video and try to see whether you can make any of them the subject of the formula. the ones on the right, right? I'll do some. For example, if pressure, this is pressure. Now if I want to make, let me say A the subject of the formula. For example, I'm doing A the subject of the formula. How will I go about it? So if I have A, so what first is an A is below the line. So I take it first up, right? So you have P times A is equal to F. And the next thing now, since P and A is together, A is not standing alone. So I'll draw another line. And I take that P down below the line. I'll have A now is equal to what? F on what? On P. And you have made A now the subject of the formula. Now if you're making P F the subject of the formula, you don't need to just need to do one carryover. Like for example, if I'm doing getting F now, we have P is equal to F on A. Now F is above the line, so A is below the line. So I take A this way. I'll have now P times A is equal to what? F. So I've made F the subject of the formula. So force is equal to pressure times area. So you can pause the video and do that for this, and do that for this, and do that for this, and do that for this. So, but if you want me to help to know your answers, whether it's correct or whether you're in line, you can join my WhatsApp group on the link in the description. Right, good. Now, the last method that we're going to look at is the method on method 3, which we have equations in the form excuse me, F is equal to x t squared. I have equations in this form. So if you have equations in this form, how are you going to solve it? How are you going to make one the subject of the formula? Very important. So you have to draw your line first. Now making t the subject. Now after making your line, what happens? X is beside t, so you carry this x this way. It's above the line, so you put it below the line to the other side. So you have f of x is equal to t squared. But now since t is not alone, there's a value here 2. There's something here. So you have to remove this 2. How do you remove the 2 now? Since it's square, you have to take the square root on both sides of the equation. Take the square root on both sides of the equation. So which one? Okay, square root. So because the anti of square is square root, so you take the square root on both sides. So your equation, we have the square root of f on x is equal to what? T. That's what you have done. So you have made now t the subject of the formula. Now if this number was 3, you would have taken cube root, which is like this, and small 3. If the number was 4, you would have taken fourth root with a 4 there. That's what you have done, so that it cancels out the 2 or the 4 or the 3 that's there. For example, we have equations in physics like kinetic energy is equal to half mv squared, which half is a number, m is a mass, and v is a velocity. And there are times they ask you to make v the subject of the formula. So how do you go about making v the subject of the formula? So what you do at times is yes, so you do the same thing. You do division, your sign, you draw your division sign, right? So this 2 is below the line, so you take it this way. So you have, and now since 2 is below, you take it above the line on the other side. Now m is below the line, you take it below to this other side, and then this 1, if you want to you take it below the line too. So what do you have? You have 2 times kinetic energy over m times 1 equal to what? V squared. So you have, at the end of the day, What do you have? You have 2k negative energy divided by mass times 1, m times 1, it remains m, will equal to now what? V squared. So now what do? We have to look now for the square root. You have to make v is not alone yet. So you have to look for the square root. And the square root. So you have the square root of 2ka on m is equal to what? V. So that's how you've made v the subject of the formula. Very important. So you can pause the video and try as much as possible to make other formulas the subject of the formula. And practice, because practice is the key. If you don't practice, you're going to not understand it better. You can feel as you're understanding why they're watching the video, but if you don't practice them, it will be difficult for you to know them. So it's good for you to look at all the equations you have in physics, like the one I've given before. Like you have a potential energy, mgh, you have work done is force times distance, you have density, mass and volume, you have pressure, rho gh, you have power, IV, you have power again, energy and time, and you have so just there are many of them. Try as much as possible to make any of them the social formula. Try to use the different methods we have taught to try to say you change one thing to another. If you practice that, and I'm always there to see or to help you, to get to confirm your answers, and also to to help you get the A that you deserve to have in this subject. Thank you once again for watching, and watch out for the next mathematical session, which will be on standard form.